Ever grappled with the concept of limits in calculus? It can seem a bit daunting, but don't worry. We're here to untangle the knots and make sense of it all. Today, we're diving into the epsilon delta definition of limits, a key concept in real analysis. At its core, the epsilon delta definition provides a formal and rigorous understanding of the concept of limits for functions. Say goodbye to vague notions of getting closer and say hello to precise, measurable conditions. This definition gives a rock-solid foundation for further theorems and manipulations. Imagine a function, fx, defined around a particular point A. The epsilon delta definition states that fx approaches a limit L as x gets closer to A. But how close is close? That's where epsilon and delta come in. For any degree of closeness, epsilon, to the limit L, there exists a corresponding closeness delta to the point A. The definition spells this out in two parts. Firstly, for every positive epsilon, no matter how small, there is a positive delta. This expresses the universality of the definition. Secondly, if x is within a delta distance of A, then the function value, fx, must be within an epsilon distance of the limit, L. This is the core condition of the definition. In essence, the epsilon delta definition guarantees that no matter how close we want to get to the limit, L, we can always find a sufficiently small neighborhood around us such that all function values within that neighborhood are close enough to L. So what are the key takeaways? 1. Epsilon is our desired level of closeness to the limit. The smaller the epsilon, the stricter the condition. 2. Delta is dependent on the chosen epsilon and defines the radius around A where the closeness guarantee holds. And finally, the definition excludes the point x equals A itself, which could be due to undefined function values or other singularities. And there you have it, the epsilon delta definition of limits explained. With this concept in your toolkit, you're well on your way to mastering the complexities of calculus.